Start lecture. एकदम perfect time पे शुरू हो रहा है. Let's quickly revise what we have completed till now. Suppose it's a magnetic field. If we throw a charged particle into this magnetic field, it will start performing circular motion, right? If we throw a charged particle like this, positively charged particle, it will start performing circular motion, isn't it?
Yes, sir.
And the radius of the circle is given by, radius of the circle will be given by mb upon qb, and we can write this in terms of kinetic energy, right? 2mke, and we can write this also in terms of under root 2mq delta v, where delta v is potential difference. So we have three formulas of radius, and we know how much time it will take to complete one turn also. 2 pi m upon qb. What else we know? Fleming's left hand rule. Thumb of our left hand will represent direction of force, and middle finger will represent velocity. Index finger represent magnetic field, and thumb represent what? Thumb represent
Force.
force. So this is Fleming's left hand rule. Force can be written as QVB sine theta, and in vector form force can be written as Q V cross B. Okay, this is vector form of the force, which tells us force is perpendicular to velocity as well as force is perpendicular to magnetic field. It means force is perpendicular to the plane of velocity and magnetic field both. Okay. For now, here you can check force is always perpendicular to velocity. And because force is always perpendicular to velocity, that's why power delivered is 0. Power is equal to Fv cos 90. So power delivered by the magnetic field to the charged particle is 0. That's why change in kinetic energy is also 0. Now, I'm not talking about kinetic energy. I'm talking about change in kinetic energy is 0. If because there is no change in kinetic energy, that's why we can say speed is what? Speed is constant. But momentum is changing. Momentum and velocity is changing due to direction, right? Momentum and velocity is changing due to direction. Okay. So magnetic field can only change direction, due to which velocity and momentum will change. Okay. Now let's start today's topic. Today we are going to learn velocity selector. What is this velocity selector? Very important concept. We will throw a charge with certain velocity in magnetic and electric field at zone. The magnetic and electric field applied in such a way that magnetic force and electrostatic force acts in opposite direction. Okay. Magnetic field and electric field applied in such a way that so that magnetic field and electric field works in opposite direction. Okay. And suppose a case Imagine a case in which electric field and magnetic field, electric force and magnetic force are same. Then the net force same and opposite. Okay, suppose in a case, suppose a situation in which electric and magnetic forces are same. So net force will become, come on, bachcho, speak. Net force will become what?
0.
0. And if net force will become 0, then what will happen? Charge will move undeflected. In such case, now read everything again. Give it a quick reading again. Come on. So we will throw a charged particle with certain velocity in a magnetic and electric field. I'll show you diagram. The magnetic and electric field applied in such a way that the magnetic force and electrostatic force acts in the opposite direction. Suppose a situation in which electric and magnetic forces are equal. They are equal, right? Then the net force will become 0. And if net force is 0, charge will move undeflected. Okay, now you want to see how it looks like, how it looks velocity selector. Let's make its diagram. Okay, the name of topic is velocity selector. Suppose this is a certain reason. Again, we have a lot of we have magnetic field into the page here in this portion. Uniform inward magnetic field. This is uniform inward magnetic field, and we are going to throw charged particle from this side. We'll throw a positively charged particle. So where magnetic field will apply force on this? Upward or downward? Come on, tell me where magnetic field will apply force on this?
Upward.
Upward. From Fleming's Latin rule. Okay. Now, if I want to counter magnetic force, what I can do? I'll create electric field. I'll put a charged sheet, infinitely long charged sheet, which will create a uniform electric field downward. This yellow arrow representing what?
Electric field.
Electric field. Okay. So a force on a positive charge acts along electric field, right? So where will be the electric force, boys? Where will be the electric force? Downward.
Downward.
Electric force will be downward. And magnetic force?
Upward.
Upward.
Magnetic force will be upward. Magnetic force will be upward. And electric force will be downward. Can you tell me value of magnetic force? QVB sin 90. Why 90 by? Because velocity and magnetic field are perpendicular. Magnetic field is going into the page and velocity is in the plane of page. So angle between velocity and magnetic field is 90 degrees. Do you agree?
Yes, sir.
Okay, and what will be the electric force, electrostatic force, bacho? If you put a Q charge in E electric field, it will experience QE force, right? Am I right?
Yes, sir.
Suppose a case, imagine a case, Sinchana. Congratulations, Sinchana, for getting highest marks in the NEET exam. I'm very happy. Okay. upward and downward force, if they are equal, then where charge will deflect, upward, downward, or no deflection?
No deflection.
No deflection. So only those charge will pass from this gap. Only those charge will pass from this gap which have a particular velocity. What I mean, if upward and downward forces are same, then we can say QVB is equal to QE, right? Can we say this or not?
Yes, sir.
Q and Q will get cancelled. So what is velocity? E by B. So because magnetic force depends on velocity, bacho, see this? Magnetic force depends on velocity. So if you change velocity, magnetic force will change. So only those charges which have some particular velocity will pass straight without any deviation. Am I right? Am I right?
Yes, sir.
Yes, sir.
Okay. So only those charges which have this velocity can pass without deviation, because on these charge, magnetic force and electric forces are equal and opposite. So net force will come 0 and it will pass straight. Okay, this is the concept of velocity selector. Okay, electric field present, yes or no? Electric field present, yes. Electric field non-zero. Magnetic field non-zero, right? Where is electric field? Downward, and magnetic field is into the page. So what is the angle between electric field and magnetic field?
90 degree.
90 degree. Okay, magnetic field is into the board. It will be perpendicular, bacho. You imagine, please imagine. Okay. And one more thing, bacho, velocity and electric field. Look at the diagram. What is the angle between velocity and electric field? They are also
Perpendicular.
velocity and magnetic field also perpendicular. So lot of situation, lot of conditions are there. There is one more condition. V must be equal to
E by B.
E by B. So these many conditions are required for a charge to move without deflection through a uniform magnetic field. These many conditions are required. Okay, electric field and magnetic field should be perpendicular to each other, and velocity should be perpendicular to electric field and magnetic field both. And velocity, the value of velocity must be this, E by B. Then only a charge will move straight without any deflection. Remember these situations. Remember this, these conditions. Very important question. It will form very important question in the exam. Okay. All right. Next topic. Understood this topic, everyone?
Yes, sir.
Yes, sir.
Okay. Now I'm moving ahead. I'm moving towards next topic. Next topic is mass spectrograph. Right? Mass spectrograph. Okay. It's a simple device, bacho. In this device, we accelerate a charged particle through certain potential difference. Then this fast moving charge velocity is known, okay? Because we are accelerating this charged particle. We know why, what potential we are accelerating it. So we must know the velocity of this charged particle, right? Fast moving charge. Then we move. Then this fast moving charged particle will enter in uniform magnetic field. In this field, we will measure radius of its path. Because when charged particle will enter into the perpendicular magnetic field, it will start performing circular motion. So how much information we have? We know radius, we know velocity. What we can find? What we can find?
Magnetic field.
We can find specific charge Q by m, right? By using velocity and radius, we can find specific charge on the charged particle, which is very difficult to measure. We do not have any device by which we can measure specific charge of electron and proton, right? हमारे पास ऐसी कोई device थोड़ी है जो इतना छोटा mass और इतना छोटा charge calculate कर पाए, am I right? So by this trick, by the trick of mass spectrograph, we can find mass also of the charged particle. You want to see the arrangement? You want to see arrangement?
Yes, sir.
Yes, sir.
Let's understand this arrangement. Very simple arrangement is there. There are two gaps. This is magnetic field. See how easily we will calculate radius of its path. See this. This is entry point. Sorry. It's silent. Okay. Imagine, बच्चों, this is a large conducting plate connected with the positive terminal of a battery. Whose negative terminal is connected by this plate. So what will you observe? Lot of positive charge will come on this plate or not? Right?
Yes, sir.
Now imagine a charged particle. Imagine a charged particle set free at rest and potential of battery is V, where this charged particle will accelerate very fast. Come on, tell me. Where this charged particle is going to get accelerated? जवाब दो, और नहीं जवाब दे रहे तो खत्म कर दूंगा टॉपिक.
Upward.
तो यार अपवर्ड बोलने में दिक्कत हो रही है क्या किसी को? जवाब देने में भैया पॉजिटिव पॉजिटिव रिपेल करेगा, इट विल एक्सेलरेटेड अपवर्ड. Charge particle will acquire velocity in this gap. Its velocity will keep on increasing because we can assume there is a certain uniform electric field in this space. Okay, there is certain uniform electric field in this space. So this uniform electric field will accelerate this charged particle. Okay, and the moment it enter into the magnetic field, the moment charged particle enter into the magnetic field, it will start performing what?
Circular motion.
It will start performing circular motion, and it will perform a semicircle inside magnetic field, and it will come out from a certain region, right? It will come out from a place. Suppose from here it is coming out, and we'll keep moving detector everywhere, and we'll conclude that charge coming out from here. Suppose if we got charge is coming out from here, then it will be very easy to find radius. Yes or no?
Yes, sir.
Yes, sir.
But how you know velocity? How will you get velocity? Very easy. Here potential 0 volt, here potential V volt. So increase in kinetic energy is what? Q delta V. So increase in kinetic energy, Q into V, and initial kinetic energy was 0. So now its kinetic energy is QV. 1 by 2 mv square is equal to QV. You will get velocity very easily, right? You got velocity as 2qv by m under root. Any doubt?
No, sir.
Okay. We got velocity. And we know radius also. R is equal to mv upon qb. We'll put value of velocity here. 2q potential, v is potential, okay? M is mass. So you can solve this. Let's square both the side. यार इधर m था ना? Yes. Let's square both the side. We'll get m square q square b square into 2qv by m. So 1q got cancelled, 1m got cancelled. R square is equal to m upon q into 2v upon b square. So we got q by m as, or you want mass or charge by mass? What do you want? But you want to calculate mass or charge by mass?
Charge by mass.
Okay, let's calculate charge by mass. You will get 2v by b square r square. What is this capital V? Accelerating potential. Understood use of this mass spectrograph?
Yes, sir.
Okay. If you have any doubt, please ask. Diagram made? Everything done? Written? Completed?
Yes, sir.
Yes, sir.
Okay. Okay. So this is how mass spectrograph work. I told you about velocity selector also. Now write next Lorentz force. Done?
Done, sir.
Lorentz force. Now what is this Lorentz force? Lorentz force, it is net force on charged particle by electric and magnetic field. Okay, it is net force on the charged particle by electric and magnetic field. So when a charged particle enter into an electric field, it experiences this much force. Okay, and when a charged particle enter into a magnetic field, it experiences this much force. But if in a certain reason magnetic field and electric field both are present, then the net force will be, if electric and magnetic both fields are present, the net force कितना आ जाएगा बोलो? QE vector plus QV cross B. This force is known as, this net force is known as
Lorentz force.
Lorentz force. Very important. Copy. Done?
1 minute, sir.
Yes, sir.
Yes, sir.
Copy slowly, write everything. It is very important for school exam.
Done, sir.
Done. Now write next topic known as cyclotron. This device is used to generate fast moving charged particle. Okay, this device is used to generate fast moving charged particle. Okay, right, working concept, working principle. So by a different color. See how it works. As we know, magnetic field can only change direction of charged particle, right? And but electric field can increase speed. Can magnetic field increase speed? Yes or no?
No, sir.
No,
No.
magnetic field cannot increase speed, but electric field can increase speed. Okay, so what we'll do, we will create we'll create an electric field in a gap we'll create electric field in a gap, and by magnetic field we will circulate charged particle again and again through same electric field to increase its speed. समझ गए? हम क्या करेंगे, मैग्नेटिक फील्ड से उसका डायरेक्शन पलट देंगे और एक जगह पे इलेक्ट्रिक फील्ड बना देंगे, अभी दिखाऊंगा मैं। तो क्या होगा कि चार्ज बार बार उसी इलेक्ट्रिक फील्ड से निकलेगा और स्पीड बढ़ जाएगी। ठीक है, राइट। नेक्स्ट थिंग, कंस्ट्रक्शन। It is made of two metallic Ds and a strong magnet. An oscillator is also used to switch direction of electric field as per requirement. Okay, completed writing.
Yes,
Done?
sir.
Okay, now let's see how device looks like. But this is a small strong pole.
कंस्ट्रक्शन थोड़ा दिखा दो सर।
It is made of two metallic Ds and a strong magnet. An oscillator is also used to switch direction of electric field as per requirement.
Sir, what is this?
I'm making metallic box. But so suppose this is North Pole and this is South Pole. Can you see two very big poles? Strong magnetic field poles.
Yes, sir.
Now what we'll do, this is a metallic box like lunch box. Okay. Why metallic? Because magnetic field can enter into the metals. Magnetic field can enter into the metal, but which field cannot enter into the metal? Come on, tell me, which field cannot enter into the magnet, into the metals? Electric or magnet?
Electric.
Electric field cannot enter into the metals. And hopefully everyone can see a gap. There is a gap. There is gap between these two D's or not?
Yes, sir.
Yes,
Make
sir.
a diagram, make a beautiful diagram. This is oscillator. I'm sorry, I could not make same D's. These are the only diagrams. Working not started yet. Give me a minute. Explain you working also. Kartikeya made this diagram.
हाँ सर
इतनी सुंदर डायग्राम बनाओगे तब कहीं जाके नंबर मिलेंगे, है ना? अब तुम
सुंदर
लोग
क्या है?
बोलोगे ये कौन सा से सुंदर डायग्राम है ना? चल देखो, ये मैं आपको डी बना के दिखा रहा हूँ, ये वो डी है ये, और ये वो गैप है. This is the gap. In this gap, we are going to project electric field with the help of this oscillator. ये oscillator electric field create करेगा. This will create electric field, okay? And there is magnetic field in the D's. Magnetic field can enter into the metals. And Bacho, there is a very small gun here. This is center. There is a small gun. This gun will keep ejecting positive charged particle upward. Okay. Suppose this gun ejected a positively charged particle just now. So where force will act on this positively charged particle the moment when it enter into the magnetic field? From Fleming's Left-hand rule, where your thumb is going. Right or left?
Left.
Very good. सबको बनता भी नहीं है ना, एक ही बच्चा जवाब देता. खैर. So it will start performing circular motion left hand side. Okay, and when charged particle will enter here, we will start electric field. We will start electric field. What this electric field will do? Come on, tell me. What this?
Increases velocity.
Correct. Electric field will increase its velocity. And because velocity is increased, its radius will also increase, right?
Yes,
Radius
sir.
will also increase. And the moment when charged particle reach here, we will create an upward electric field, right?
Yes, sir.
So other side electric field was downward, and now this side is electric field is upward. Means with the help of oscillator, we'll have to change direction of electric field again and again, right? Again in this gap, its speed will increase, so its radius will increase further. Again its speed will increase, right?
Yes, sir.
Yes, sir.
Why I will have to increase density. Okay. Now again its radius will increase and velocity will also increase. In this gap, again its velocity will increase. Again radius will increase. And when its radius will become maximum, it will come outside. You understand that?
Yes, sir.
This is fastest moving. You understood how it works?
Yes, sir.
Yes, sir.
There should be no doubt now, right? So what we are doing, we are creating electric field, and we are making charge particle move through a certain electric field again and again. Suppose in this gap, the potential difference is V. Okay. Suppose in gap, potential difference is V. Okay. So when charge particle pass gap once, how much kinetic energy it will gain? Change in kinetic energy, gain in kinetic energy, gain in kinetic energy when charge
Q square B square by 2m into R square.
pass potential V once. So you can say kinetic energy is equal to Q into V. Do you remember that formula, Q delta V?
Yes, sir.
Okay. In one turn, how many time, कार्तिकेय? एक चक्कर में गैप से कितनी बार निकलेगा? 2 बार, है ना?
हाँ, sir.
In one complete revolution, charge passes gap twice. So after one complete turn, delta KE कितना होगा? QV और 2QV? 2QV.
2
After n complete revolutions,
2
what
N
will
Q
be?
V.
Correct,
2
correct.
NQV.
2 and QV, gain in kinetic energy. Okay. There is one more clue, bacho. You have one more clue. Suppose this is equation A. What I told you, when fastest coming charge must have radius equal to this, right? Radius equal to radius of D, right?
Yes, sir.
Agree? So if we use maximum radius, its velocity should be final velocity, right? Yes or no? When
Yes,
we
sir.
use maximum radius,
Yes, sir.
velocity should be final velocity when it is coming out. So we can say that final velocity is R max QB by M. This is final velocity, right? So what is final kinetic energy according to this concept? Half mv square. Final, right? So 1 by 2 m. इसका स्क्वायर करके लिख दो. R max square Q square B square by M square. So 1 m got cancelled. So this is final kinetic energy according to the radius concept. But according to the potential concept, this is maximum kinetic energy. So this kinetic energy and this kinetic energy must be what? These two kinetic energy must be what?
Equal.
Equal. Very good, very good. So we can write R max square Q square B square divided by 2m is equal to 2n Q delta V. Okay. So by using this equation, we can find a lot of unknown as per the question, as per the requirement. Okay. Understood cyclotron, everyone?
Yes, sir.
Yes, sir.
Any doubt, any small doubt, please ask. No doubt?
सर गन पे अगर नेगेटिव चार्ज रखते
तो उल्टा घूमता। क्या पूछता है रे? पूछो तुम ये, this should be your doubt. Sir, how we are changing direction of electric field? Or who will tell us when to reverse direction of electric field? Because velocity and radius both are changing again and again. So how this oscillator knows when charge will reach? This should be your doubt, but no one asked this doubt. Oscillator no need to think, because the time period is independent from radius and velocity both. You see this? So even if velocity is increasing, radius is increasing, but it doesn't matter. Charge particle will take same time every time. You understand that? After every this time, oscillator will have to reverse direction of electric field. Okay? Agree, bacho?
Yes, sir.
So no problem even if velocity or radius is changing. Okay? Now, if you have any other doubt in your mind, you may ask. From velocity selector, mass spectrograph, from anywhere. Any doubt?
All clear, sir.
All clear? Okay. Even if you have doubt, you can watch IIT lecture also. Okay. There is one IIT lecture already there in the YouTube. If you want to see that lecture, tell me. I will send you link. Okay. And for CBSE student, there is a good news. Cyclotron is removed from the syllabus. But Karnataka board student will have to read this cyclotron. But CBSE board student can leave.
सब बट नीट के लिए थोड़ी ना छोड़ सकते।
Yes, NEET. It will come in NEET.